All right, our last part then is finishing up these two questions that deal with writing in vertex form, sometimes called standard form of a parabola. Thinking about this, we are going to finish those two out, and then we have our question that might be a hint at the cumulative part of this first cumulative test. So find a quadratic in vertex form that has the vertex given of -3, -2, and passes through the point 3, 4. Well, before we can write in vertex form, probably helps to write down what is vertex form, which is y equals a times x minus h squared plus k. So I'm going to leave these ones each as a color. These are the things that should vary in our final answer. So every parabola has inputs that are x's, that are quantities squared, because that's the definition of our parabola, right? Quadratic function that gives us our output y. The reason parabolas look different is because of where their vertex is located, hk, and their vertical stretch or shrink, the part of a, right? Also could be a reflection as a transformation. So thinking about this, my final answer should be this, but I need to fill in a, h, and k. So y equals, I don't know what a is. I know what h is. Here's h right here because of the vertex. So -3 really would turn this as a +3. And then my k value, here's k from the vertex, will become -2, which means the last mystery piece here is what in the world is a? All right, well, I don't have a, but I have this point right here, which represents x and y. So since I have information for x and y, and I just need my mystery value of a, I can use this same equation that I have set up, except replace the y with the 4. A, I still have no idea. X now is going to be 3. H, we said, was turned to that +3 squared, and then -2. Well, look at this. All I have left to solve for is A, that vertical stretch or shrink for my parabola. So let's clean this up. I got 4 equals 8 times 3 plus 3 is 6 squared minus 2. So 4 is equal to 36a minus 2. 6 is equal to 36a, which means a is equal to, careful, divide by 36, 1/6. So fill in that 1/6. There is my function in standard form that goes through the vertex of -3, -2. And if I plugged in 3 to this equation, I will get back an answer of 4. So again, you work there to find the mysterious vertical stretch or shrink, because we know where the parabola is going to be shifted to with the vertex. We just need to figure out how tall or how short our parabola is going to be, and if there were or were not going to be a reflection. All right, write the following in vertex form. Okay, so again, we're trying to get to this vertex form of y equals a times x minus h squared plus k, thinking about our horizontal shift, vertical shift, and our vertical stretch or shrink. And then we've got some follow-up questions, which we'll get to once we have our equation in this form. Well, this right here looks like I need a perfect square binomial, and we know that to get a perfect square binomial, we would need to complete the square. So step 1 in completing the square, divide everything through by your leading coefficient, which would have been 2. So I get f of x over 2, because I don't know what that is, equals x squared plus 6x minus 2. The next step is to move your constant term to the other side. So f of x over 2 plus 2 is equal to x squared plus 6x. The next step is when we actually complete the square. So I'm going to take half of my b value. I'm going to square it. So that would have been 3 squared, which is really 9. So I'm going to add 9 on this side and add 9 on this side. So on the left, I still have f of x over 2. 2 plus 9 gets me 11. On this side, the whole purpose was getting a perfect square binomial, perfect square binomial, and the number that goes there is the number that I squared. Which, if you double check, x plus 3 squared would be x squared plus 3x, which is 6x, plus 3 times 3, which is 9. Closer to this perfect function notation for vertex form. Next thing that is going to be to start getting f of x by itself. right? We're not solving this like we would solve the quadratic. We are looking to write in standard form. So this would be minus 11. Last step then is to multiply through by that x, by that a value. And remember that the 2 needs to distribute to that 11 as well, because we would multiply this whole thing by 2, so those cancel. And then 2 on this side would need to distribute to both terms. So in vertex form, we have 2 times the quantity x plus 3 squared minus 22. That is equal to our function. So what we just found is that this equation in red and this equation in blue, they are exactly 100% mathematically equivalent. If you were to distribute out this x plus 3 squared, multiply it by 2, and subtract 22, you would get this same thing. This is just a different way of looking at it so we can answer some different questions a little more easily. For instance, what is the vertex of this function? Well, the vertex comes from our h value and our k value. So negative 3, comma, negative 22. Because this function would have moved to the left 3 and down 22. The y-intercept by mathematical definition is in goes 0 for x, what comes out for y. So this one you could do from either this form up here or from our vertex form. I'm going to choose this one, so 0 plus 3 squared minus 22. So 3 squared is 9, 2 times 9 is 18 minus 22, which is negative 4. Some people might view it easier to take that from standard form. That's totally fine. The last part then is what is or are the x-intercepts? Well, x-intercepts is what happens when you set your y value equal to 0. We're looking for what is x equal to. All right, well, I could start by setting this thing equal to 0. And then this I could see, take out a GCF of 2, and then maybe try to factor this, see where we get to. Or I already just did this with the perfect square. I'm going to use that instead. And I'm going to say 0 equals 2 x plus 3 squared minus 22. Again, could I multiply this all out and then try to factor or quadratic formula? Sure. But I think it's more straightforward to add the 22, divide by 2, and then undo the square. So we're going to get plus or minus the square root of 11 is equal to x plus 3, which means my x itself is equal to negative 3 plus or minus the square root of 11, which should be the same answer you would get if you use the quadratic formula on the original function. All right, the last part then is reviewing something from back in Unit 2, but it's something that's going to be really important throughout the rest of your math career, especially in calculus. So here we have the graph of f. I'm going to say that it is okay for us to assume, also because I'm telling you and I'm the one that made the graph, that we are counting by ones here. So all things considered, each box is equal to 1. So state the domain of f of x using interval notation. Well, domain, we think about the x-axis. So from left to right, if you were to squish all of this down to the x-axis, you cover the whole thing. Negative infinity to infinity. For the range, we want to think about the y-axis. So I'm going to take this point, move it over to the y-axis, and then it's going to go forever up. These two also are going to squish to the y-axis going forever up. So it looks like we have negative 3 including until infinity. Intervals of increase going up the roller coaster. We use only our x values to talk about it. So this would be negative 3 until 0. And then from 3 until infinity. Thinking about decreasing, that's going to be going down the roller coaster. So we started going down the roller coaster at negative infinity. Sorry, the yellow is kind of hard to read. Until negative 3. And 0 until 3. Is there ever a place where this function is constant? No such interval. So something to note here. We said our domain was negative infinity to infinity. That means that our increasing, decreasing constant has to cover that whole interval, because your function is doing one of those 3 things at all times. It's either increasing, decreasing, or being held constant. So negative infinity to negative 3 to 0, 0 to 3, 3 to infinity. I've covered from negative infinity to infinity. Okay. Next thing then, at what coordinate point, if any, does the absolute maximum occur? Well, the absolute maximum is the absolute highest point, and we're looking for a coordinate point like this. Well, we said the range, the highest y value is infinity. Can that be a point? Hopefully you just said no. In which case, there is no absolute max because this function is going to infinity. At what coordinate point, if any, does the absolute minimum occur? Well, the minimum coordinate point, that would be talking about the lowest value. So our lowest value, we said, was negative 3, and that happened when x was equal to 3. Last thing then, list the coordinate of a relative minimum of the function. So in this case, there's only one relative minimum, and that's going to be over here at negative 3, 0. And it's relative because this side was decreasing, this side was increasing. Relative to the things around it, the point negative 3, 0 is a low point because 0 is a lower y value than the points surrounding it. All right, that's it for your first cumulative review video set. Hopefully you learned a lot, reviewed some, and feel prepared for your cumulative test. If you're still stuck on anything, email your teacher, make sure you come in for extra help, and go back and watch some videos from the unit to refresh your memory on things.